if your aquarium keeping skills are up, and you're doing all your proper maintenance, you're doing your water changes, and you're using a good water, a good water going back in the system, you can get away with less rock, because I know you're setting up that new one, right? You're setting up the new tank, and what are you linking it together still, or are you not doing that anymore, or what?
No, it's just one single.
Okay, because I know you were linking something together before you changed that. So, I mean, if you have a 500-gallon system, you don't need 500 pounds of rock. I mean, this total system here is maybe with the sump, volume of water and everything, 700 gallons, and there's little rock in here. I mean, this is my main bit. A lot of it's corals and stuff. That one is even less. There might be 150 pounds in that 600, 700 gallon system, but the circulation around that rock is substantial enough so that all that bacteria is getting the water flow with all the ammonias and stuff around it to nitrify it. So, I mean, you can go bare bottom in a 100-gallon tank and put 60 pounds of rock and be okay, as long as your husbandry skills are up and you're doing all your water changes and everything.
Do you ever remember that last symposium in Maryland?
Yes.
Anthony's thing is
we were doing way too much rock. And he's right, because typically and I did it in the reef display, but I did it because I need the space to really to really show off stuff. But I mean, you can get away. The best thing is have flow behind and in front of it, and that's a good point, because he did bring that up. A lot of us just pound and crowd the tank with rock. It's not only displaces so much water, to where your water volume is substantially depleted, and then again you've got less water, less room for error, so forth. So what we want to do is air stack the rock. Aquascaping is going to be a big one. We're going to probably do a whole thing on aquascaping, water flow, protein skimming and filtration, and get all onto that. So I mean, if you're setting up new tanks, I know a lot of you guys are setting up new tanks. You don't have to pound that thing full of rock, but you do have to have enough flow around the rock. That's what's important. That flow that's going around the surface area of the rock, keeping the nitrifying bacteria in a perpetual cycle. That's really what we're looking for. Good point though. There, filling them up. Anything? Everybody good on that, right?
What about a frag tank? We have a frag tank dirt bottom.
Yep.
So,
and it's mostly frags.
Right.
I mean, if anything, I would just put rock in the sump if you're like you do, because you have the frag tray. Right. It's a frag rack, right, and there's not much rock in there. I mean, it's kind of like, that system is not really much rock in it. Right. This one has a little more, but that one's not much rock. It's the same kind of thing. Bare bottom. I don't have anything in the sump, no bioballs, nothing in there. But the flow and your protein skimmer is going to come into a big play there. I mean, are you having any issues?
No.
Pretty much everything's staying zeroed out. Because it's a perpetual cycle and you're good. I mean, weekly water changes, 10 days? Bi-weekly? Oh, I seen the growth. I know what's going on. You brought those frags in. They're starting to puddle all over, man. Looks good. Yeah. So, I mean, frag tanks, the smaller the volume of water, less room for error, though. You got a little tank, and one little mess up, it causes big problems. I mean, the larger amount of water, more room for error, but if there's a problem, it's a bigger problem. So you got to watch that too. Big tank, big problem. Small tank, small problem, but it can consume the system faster because you have less room for error. So we're good on that. Anybody? Nitrogen cycle, pretty basic. Everybody understands the ammonia conversions to nitrite, nitrate, and then the nitrifying bacteria, nitrobacters. Cool deal. Look at that. Look at this. Is everybody testing? Some of us are guessing. I know some of us are guessing. A lot of us out there just guessing, not measuring, just kind of, that's enough type thing. We're going to find out how that's bad. High levels are sometimes more dangerous than low levels. How's yours doing? I haven't seen any pictures in a while. I figured you were waiting for it to clear up before you showed it off a little bit. Well, everybody knows what I went through with this tank. I mean, everyone that was here in the first, 2 months we were open, the thing was a nightmare. It's finally gone. It took 4 months though. I mean, it was algal bloom, man. There was everything in there, but it's pretty clean now. It cleared up, so coming around. All right, we're gonna go over natural seawater levels and then contained environment. levels, because that's going to be, you know, they're a little different. We keep things a little different than Mother Nature, but it's a contained environment, so we've got to really watch these factors. Natural seawater, 70 elements plus. It's just about every element known on Earth is in seawater. I mean, it's in there. If there's an element on Earth, it's in seawater. So if that tells you anything of how complex this is and how there's no way I'm going to get to everything. I don't even know everything, so I can't get to it. But we're going to come close. We're going to hit all the major points, hit some of the stuff that we're all overlooking. There's a lot of stuff we're overlooking, even myself. You know, we're overlooking stuff, you know, our tanks are doing great, everything's fine, and then bam, and we wonder why. It's because we really need to keep the testing. So if you guys aren't testing, that's going to be something I'm going to push on you today, is testing and then supplementing. And if you're not testing, you really shouldn't be supplementing and guessworking, because you're going to get in trouble. So all the corals, fish, inverts, algae, they all use all these elements for a biological process. So they're all important, all the elements, and we're going to get 95% of them in just our regular water change. A lot of them we're not going to get out of a water change because all the salts are different. Oceanic's high calcium. You know, reef crystals is high calcium. Some of your lesser expensive salts, lower trace elements. So we're going to find that just water changes aren't going to do everything. Now you can go with some of the better salts. Everyone knows Tropic Moran, the Tropic Moran lineup. Those guys know what they're doing. They make the best salt out. I haven't found anything to match it yet. We've been through that. Beat that horse again. But we do need to replace them. If we're not replacing them, our corals aren't growing, you're wondering why. All these levels are imbalanced, your calcium's up, it's down. So we're going to go over that. Obviously, in the wild, everything's replenished naturally. It's all out there. All the elements are naturally available. It's all replenished. Contained environment, closed system. If you don't put it in there, it's not just going to happen. We got to put it in there. And we got to test what we're putting in. Especially some of the, even some of the minor elements like iodine. Man, if you're dosing iodine, you got to be specific, and you really should be testing. It's a hard test, though. I don't even like to do that one, but we're going to have to go over it. All right, we got our major elements. Calcium, strontium, and magnesium. A lot of people overlook magnesium. That's a big one. Everybody's calcium, 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 but that's not the only one. You got to have the mag. Got to have the strontium. Your alkalinity needs to be right. Your pH. Everyone knows about acid and alkalinity. The acid's, you know, bad. So our major ones, calcium, strontium, magnesium. Those are our major ones. Minor elements, iodine, iron, molybdenum. Everyone's heard all those terms. All those elements, everyone's heard them. Some of us haven't heard borate and, you know, manganese and cobalt and some of these other ones. We don't need to dose those because they're in the salts. There's enough traces in there. I mean, we need less than 0.1% of some of these, which is, you know, we're talking parts per million, parts per thousand, really fine increments. We're gonna have to be on our game here to keep stuff looking well. Like everyone knows, I got that from Steven in Suffolk. Now all that whole system was his, aside from a few new pieces I got in. He grew that in 4 years from frags I sold to him out of my garage 4 years ago. So optimal conditions, optimal growth, optimal lighting, water quality, all that. You Tropic Moran guy. That tells you something. I'll try and sell you some of this stuff today. You know that because you're not using it. So this is going to help you guys to really get to the point you want to be, to see the growth, to see the, you know, the process really happen right before your eyes, to see things growing on a weekly basis, and you know you're going to have all these anaerobic bacteria going on, and all these, it's everything doing what it's supposed to do. Let's do calcium first. Everybody wants calcium, so we're going to do calcium first. Natural seawater, pretty much globally, I mean, all over the world, an average of about 410. Everyone says 420, 420, 420. And that's not really true. It doesn't have to be 420. High 300s to even mid to upper 400s, your coral is going to get enough calcium out of that amount in the water to do what it needs to do. But I know everyone's 420. You know, that's like the magic number. It's really not. You know, high 300s, mid upper 400s, really